In a world where energy controls everything, a dark force threatens to consume all warmth. From the depths of space, Venom, the devourer of heat, descends upon Earth, absorbing all energy and leaving cities frozen. The planet is on the brink of extinction. The International Science Station, ISS, sends a distress call. Only 2 warriors can stop this catastrophe. Thor, the god of thunder, arrives, wielding exothermic energy. His power releases heat, melting ice with every strike. Meanwhile, Doctor Strange steps through a portal, channeling endothermic energy. Unlike Thor, he absorbs heat, redirecting energy to control the battlefield. But as Thor attacks, Venom grows stronger. Every blast of fire only fuels his hunger. The world grows colder with every second. Strange realizes the truth: energy must be balanced. If they keep attacking, Venom will never fall. They must work together. Thor releases controlled bursts of heat, while Strange absorbs and redirects excess energy. Slowly, the tide turns. For the final blow, Thor summons a lightning storm, while Strange opens a portal, channeling absorbed energy into a concentrated blast. They unleash a perfect fusion of exothermic and endothermic power. The battlefield erupts in a vortex of fire and ice. Venom screams as he is overwhelmed, his dark form dissolving into mist. The frozen world begins to thaw.
Assalamualaikum warahmatullahi wabarakatuh. Dear student, welcome to today's lesson on thermochemistry. Yes, before we begin, let me ask you a question. Have you ever watched an epic battles and wonder, what science has to do with it? What if I told you that the battle you just watched between Thor, Doctor Strange and Venom was not just about superheroes, but about a battle of energy? Yes, the secret behind their powers basically lies in exothermic and also endothermic reaction. Yes, basically student, thermochemistry is the study of how heat energy change during chemical reaction. Just like in the battles, some reaction release energy, making the surrounding hotter, while others absorb energy, making the surrounding colder. Yes, today I'm going to show you how the same battle of energy happens in real life, all around us, every single day. Every chemical reaction involves a transfer of energy. This energy can be either exit the system or enter the system. If energy exits, the surrounding get hotter, just like when the Thor released a massive lightning attack. But what if energy enters? Well, the surrounding gets colder, just like when Doctor Strange absorbed an attack to neutralize its effect. This brings us to 2 important scientific terms, which is, the first one is exothermic reaction and the second one is endothermic reaction. Exothermic reaction release energy, usually as heat or light, making the surrounding warmer. Endothermic reaction to absorb energy, taking the heat away from the surrounding and making them colder. Endothermic reaction happen in everyday situations, such as burning fuel in the car engine, which is release heat energy to power move. On the other hand, endothermic reaction include melting ice, which is absorb the heat from the surrounding, just like the Doctor Strange pulling in energy to create the shield.
Teacher, I want to ask, if exothermic reaction makes things hotter and endothermic reaction makes things colder, then why does sweating cool us down?
Well, great question, Adam. Sweating is actually an endothermic process. When your body overheats, it actually releases the sweat, which then evaporates. But for sweat to turn into vapor, it basically needs energy, so it absorbs the heat from your skin, cooling you down in the process. That is your body using chemistry to regulate the temperature, just like the Doctor Strange using energy absorption to control his environment. I guess my response is answering your question, Adam.
Thank you so much, teacher. That's very fantastic answer.
Now student, let's put this into action with a real exothermic versus endothermic battle in the lab. In the first experiment, we add zinc powder to copper to sulfate solution. As the reaction occurs, the temperature increases and the solution change color. Look at this. The reaction is release heat, which means this is an exothermic reaction. Next, in the second experiment, we mix baking soda with hydrochloric acid. The reaction starts bubbling, and when we touch the beakers, it feels cooler. So this reaction is basically absorbing the heat, making it an endothermic reaction. Now student, to make this concept stick, let's use a simple mnemonic trick. So exothermic reaction release heat. So think of azo. How many of you knows about azo group K-pop? Well, basically this one of mnemonic will help you to remember what is exothermy is all about, by which E stand for energy, X stand for zit, exit, and O stand for outside. So energy, zit, the outside. Exo, which is the energy is existing. Now for endothermic reaction. Now student, we have come to an end. So remember my words, science is all around us. Every chemical reaction from lighting a match to your cooking meals involve energy changes. Understanding thermochemistry not only helps us appreciate science but also helps in fields like medicine, engineering and environmental study. See you in the next lesson. Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much, teacher. That's very fantastic answer.
To make things clearer, let's take a look at the energy level diagrams. In an exothermic reaction, the reactants start with more energy, and as the reaction happens, energy is released, leaving the products with lower energy. Imagine dropping a ball from a hill. Energy is given off as it rolls down. In an endothermic reaction, the reactants start with lower energy, and as energy is absorbed, the products end up with more energy. This is like pushing a heavy box up a hill. It takes energy to get it into the top. Just like in the battle, Thor's exothermic attacks release the energy, while Doctor Strange's endothermic shields absorb the energy to create the balance. Now student, let's put this into action with a real exothermic versus endothermic battle in the lab. In the first experiment, we add zinc powder to copper to sulfate solution. As the reaction occurs, the temperature increase and the solution change color. Look at this. The reaction is release heat, which means this is an exothermic reaction. Next, in the second experiment, we mix baking soda with hydrochloric acid. The reaction starts bubbling, and when we touch the beakers, it feels cooler. So this reaction is basically absorbing the heat, making it an endothermic reaction. Now student, to make this concept stick, let's use a simple mnemonic trick. So exothermic reaction release heat. So think of azo. How many of you knows about azo group K-pop? Well, basically this one of mnemonic will help you to remember what is exothermy is all about, by which E stand for energy, X stand for zit, exit, and O stand for outside. So energy zit the outside. Exo, which is the energy is existing. Now for endothermic reaction, absorb heat. So remember about endo. So energy needs to be taken in. So the energy is entering the system. So this trick will help you to more better understand and how to differentiate between these two reaction types easily. Now student, we have come to an end. So remember my words, science is all around us. Every chemical reaction from lighting a match to your cooking meals involve energy changes. Understanding thermochemistry not only helps us appreciate science but also helps in fields like medicine, engineering, and environmental study. Keep exploring questions and remember, energy is always changing around us. So see you in the next lesson. Assalamualaikum warahmatullahi wabarakatuh.